Hi, welcome back to the lesson 4 in which we were learning about functions in C++. Up until now, we have learned a lot about functions and pass by value, pass by reference, returning values, passing arguments, and also function overloading. Today, we will have a look at the concept called recursive functions. What are recursive functions, how do they work, and what are the pros and cons of recursive functions? So do watch this complete video because many students find it difficult to understand the concept of recursive function, and actually it is also a bit complicated as well. So stay chill and relax and watch the complete video, and if there is any doubt, so you may let me know in the comments as well. So let's start the lecture. Starting with the basic definition of recursion. Recursion, a function that calls itself, is known as a recursive function, and this technique is known as recursion. Let's see how recursion works. This is a function which is named as recurse, and within the recurse function we are calling the recurse function as well again. So this means we are calling the function within the function itself. When we call the function within the main function body, it goes up to this function, and within that function, when we recall this function again, it will be recalled itself. Now it sounds like a confusing concept, but let's have a look in the compiler and let's demonstrate the recursive function with a simple example. Let's go. Alright, welcome to the code blocks window. So let's design a simple function that will be an infinite recursive function, maybe. So let's have a look. We will print cout hello world, and we will call the print. Okay. Now to initialize this or call this, we will call it into the main function. Let's have a look what will happen now. This is an infinite recursive function. So what's happening here? This is what is happening. Just remove this semicolon from here and let's see. So you see hello world, and it is going on infinitely, unstoppable. Why? Because what I am doing is that I am calling this function print, so it goes like here. So when I call this function, it comes here and it calls this function. It comes into this function. So it prints out this. Now in the next line, it encounters what? It is encountering the fact that it is calling again itself. So it goes back here again. Then when it comes to hello world, then after that it goes to print, then after that print. So this is going infinitely. So we can use different conditions and different decision control statements to control our recursive functions according to our needs. Now let's adjust this function on the basis of some needs. So we will say integer num is equals to 10. Let's initialize num by 10. We will pass this num. We will pass this num here, and we will receive this num here, integer num. Okay, we will receive this num here, and we will print a condition within the function. We will say if the value of num is equals to 0, then what you should do? Then you should just return from there. Okay, just return from there, and returning nothing, return just null. Okay, but else if the number value is something else, then what you should do is to print hello world and return num minus 1. So let's see, will it work or not. Okay, we cannot return. Okay, we are returning nothing, so we do not need any return. If this is equals to this, then we will have just a simple. Simple. So it's still going on hello world and nothing is happening. All right. So what seems to be the problem here? Okay, the problem is that we are not using brackets here, so it is not actually calling this function. Now let's have a look. Yes, you can count this hello world. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we did here is that we initialized a value num is equals to 10. We passed this number. Now it checks if the num is equals to 0. So we can redesign this function if the num is greater than 0. If the num is greater than 0. Or we can say if the num is less than 0. Then do all of these things. Then do this. Cut, paste. Okay? Do this, else do nothing. So we will just remove this else statement from it. So what's happening? Let's print. Okay, nothing is happening. That is really good. That is really good. Okay, so what happened just here? Okay, if num is less than 0 and greater than 0, now it will do something. Okay, it's printing the hello world. Now, what's happening here is that we have passed the number, okay? So, a number is received here. So, first of all, in first line of code, in line 6, the compiler checks if the number is less than 0 or the number is greater than 0. So, number was 10, so number was greater than 0. Then it printed out the hello world. After that, it recalls itself with num minus 1. This means 10 minus 1. So, now there is received a 9. Then 9 is being checked, num is less than 0 or num is greater than 0, and so on until it encounters that num is not less than 0 and also num is not greater than 0. So that means num is equals to 0, and for num is equals to 0 we haven't defined anything within the function, so it's not calling itself, it's just called this hello world for 10 times. I guess with this just simple demonstration, I could have just went with a really difficult example like showing how factorial can be calculated, Fibonacci series or anything else, but I just want you to demonstrate it with this hello world simple example, because visualizing recursion is really difficult task, and also making dry run of recursions is very difficult task. One thing let me tell you, that these functions are gone up to the last value. For example, when this number reaches the value 0, after that each function is performed. We will have a look at this with the example of finding the factorial of a number with the recursive function. So let's have a look at that example. Alright, so let's design a function that will calculate a factorial for us. So I hope you guys have the idea of factorial, but let me just remind you. So what does factorial means is that when we enter the number 4 factorial, it means that we have to multiply 4 times 3 times 2 and times 1, and the result will be equals to 4 times 3 is 12 times 2 is 24. So factorial of 4 is 24. Okay. So this is what the factorials mean. Okay. So we should design a logic now for a factorial of a number with the help of recursive function. So first thing first is that we will receive a number. We will take input from the user. So we will say that cout enter any positive number. So we will say integer number is equals to cn, and we will take number as our input. So this is our input, okay? So we took input from the user. We are getting input from the user. Now we will be passing this input to the function. So let's call that function as a factorial, and we will have a returning value this time. So the returning will be an integer value, and we will have a factorial. So to find the factorial, we are actually receiving a number. So we are receiving a number. Now let's have a look at the conditions. If number is equals to 0 or number is equals to 1, then what we should return? Return only 1. Why we should return 1? You guys already know in mathematics we say the factorial of 0 is 1 and the factorial of 1 is also 1. So if any situation, if in any case the function receives such number that is equals to 1 or that is equals to 0, will return 1. Now there is another condition, that is else. Else. We will say else if the number is greater than 0. So we will define some code in here, and else, in another else, we mean to say that it is an invalid number. Invalid number. Okay. Why invalid? Because we do not want to find the factorial of any negative number. So invalid number, and in this case we will return -1 because there no exist -1 as a factorial. So this will show us that there is some error. So don't focus on this condition. This is just to modify a code much better way. The main thing is here going on. Okay. So now, if the number is greater than 0, what we should return? We should return the multiplication of one number with the decrement of another number. Let me show you why. For example, I will just... Okay, for example, if I have a number of 3, so I have number 3, so its factorial is equals to 3 times 2 times 1 is equals to 6. Are you getting my point? Okay. So in function, if the number is equals to 1, it will return 1. Okay. If the number is greater than 1 or greater than 0, so greater than 0 is also equals to 1. Okay. So if the number is greater than 1, we will move on to this piece of code. Okay. Are you getting my point? Okay, I hope so. You guys are getting my point. Now what we will return as value? So if I return a function calling the number with the decrement of itself, for example, the number that is 3 with the decrement of itself, that is 2, then also returning this with the decrement of itself, that is 1. So this shows us that we want to multiply the number with the decrement of itself. Okay. So this means that num multiply by num -1. Okay. So let's have a look in the program. So we have number greater than, so we will return what? We will return num is representing that 3 that we just demonstrated, multiply by calling the factorial again here with num -1. So are you guys getting my point? And here we will receive a number here. So integer result. So result is equals to, we will just call the factorial by passing the number. Let's see will our function work or not. Okay, enter any number. We have 3. So it's not printing anything. Why it's not printing? Because we are not printing our result. That's very sweet. Man. Okay, now let's see. So 3, it should return 6. That's sweet. and for 4 it should return 24, and for 0 it should return 1, and for 5 it should return 120. So our function is working properly. And for -9 invalid number, result is equals to -1. So our recursive function is working flawlessly, and we learned a lot about recursive function. Now for those of you who are still confused, I will suggest you watch the first example that we performed. In a simple way, I discussed the concept of recursion. After that, you should move towards this example in which we have discussed about the example of factorial. Okay, so this will give you idea about how the recursion works as well, and we will perform some practice problems in which we will demonstrate further and practice further about the recursion topic as well. And for now, this was the practical example of recursive function, and you could have done this same task with the loops as well. But just to understand the concept of recursion, I performed this example here in front of you. So now let's have a look at more theoretical depth about recursive functions. Let's have a look. Okay. So recursive function is a powerful programming technique that involves a function calling itself to solve a problem. While recursion can be elegant and effective in certain situations, it also has its pros and cons. So let's have a look at its pros and cons. So simplicity and readability. In some situations, you may encounter some problems that may be very complex to get it done with the help of iterations like loops. But it may be very easy for us to just organize that code and perform that task with our recursive function. Divide and conquer. It is one of the most useful technique that we will be learning in data structures and algorithm, and that is obtained with the help of recursive functions, and recursive function is so much useful there as well. In some mathematical representation, we may use recursive functions as well. In dynamic data structures like nodes, graphs, trees, and data structures, it is also useful. In functional programming paradigm, recursive aligns well with functional programming concepts and can be used to implement functional algorithms effectively. So what are the cons? Stack overflow. Recursive functions, remember that maybe someone asks you in an interview that which kind of memory does a recursive function takes. So recursive algorithms consume stack memory for each function call. And also I may recall you that we discussed the stack memory in very depth and also the heap memory as well. So if your recursion depth becomes too large, for example, in factorial, if we are finding such kind of number factorial that is very large and consuming a lot of data and a lot of space, or maybe some another operation we are performing with recursion and the value of input is so large that it overflows the stack memory, so your program will crash. So this is the cons of a recursive function, and it is not an efficient technique in some situations due to this memory reasons and also some other reasons as well. Harder debugging, as I told you that I was demonstrating about the factorial, this was the simple program, just 3 multiplied by 2 multiplied by 1, but it was hard to explain. So if you are solving questions with recursive functions, so you may find it very difficult to debug or to visualize its outputs and its every iteration. And recursive code may be harder to maintain and modify in some cases, because if it's harder to read, harder to understand, harder to visualize, so you will face situations in code maintenance as well. And it's not always the best solution to go with. When to use recursion? So let's have a look when to use recursions. So recursions can be very useful as already discussed before in data structures, in nested data structures, trees, traversing trees, graphs, etc. Recursion may lead to the more straightforward and readable solutions comparable to an iterative approach. You will understand this point in binary search very well. In binary search can be implemented with the help of loops and can be implemented with the divide and conquer and recursive function technique. But you will see that that technique required just few lines of code and the loops were difficult. So in that case, recursive functions were helpful. Use recursion when you need to apply divide and conquer strategies as already discussed before. When to avoid? Avoid recursion when the problem can be efficiently solved using iterative approaches or other algorithmic techniques. Avoid recursion if the depth of recursion might be very large and could cause stack overflow issues. So keep memory in mind. So memory is also a big thing, and understanding data and memory and allocation, this is also one of the useful concepts in programming as well, and it will make you a good programmer if you design such solutions that they are efficient, fast, clear, and accurate. Avoid recursion if it makes the code overly complex and reduces code maintainability. If there are no restrictions and you are open to use any other technique, and you think that your recursion technique can make your code complex, so you should avoid using it. So this was a little bit basics about recursive functions. I hope you got the basic idea of recursive functions, how they work, and what are the pros and cons of the recursive functions. I'll meet you guys in the next part of this lesson where we will perform some practice problems based on the lesson 4, which is functions. So I'll meet you guys there.